Each of these objects is in static equilibrium, meaning that the sum of the forces on them is equal to 0. They're stationary, they're not moving, the acceleration is 0. I want to talk about today the force of tension in these two strings. And for clarity's sake, let's just call each one that's on the left side the left string, and each one that's on the right side the right string. And so if you hang something like a necklace from a string, then the tension in these two ropes will be the exact same. The free body diagram of this, you'll have the force of gravity down, and then you have two tensions going up, the force of tension on the left and the force of tension on the right. I'm just going to call this FL and FR. These are straight up and this is straight down. The sum of these upward forces will equal the sum of the downward force. That's not complicated at all. Maybe a little. So when you move on and the strings start to spread out, still the left force and the right force, when these angles are equal, the force of tension on these two ropes or these two pieces of this string will also be equal. And so the free body diagram for it, you'll have the force this way that's going right and the force this way going left. Now, notice how the x component of these two forces here and the x component here are going to be equal and opposite. And then you have the y component here, upward force in the y direction, upward force in the y direction. Those forces in the y direction will be equal. And so if you sum them together, your downward force should be twice as big, force of gravity going downward. Okay, things start getting a little more complicated when the angles are not equal. And just want you to think for a second about this example here. Which rope would have more tension, the left rope or the right rope? Which one would have more tension? Okay, so I'm going to go ahead and draw my free body diagram. And it might not be, I might not draw the forces to scale at the beginning, and then we'll talk about what's going on. So here's my right rope, right? It sort of goes this way, force of the right. And then my force of the left is this way. Okay, force of the left. Now, when I look at this, same idea here, that this x component here of the right rope should be equal and opposite to the x component of that one. I didn't do a very good job of drawing that. So I'm going to pause the video and I'm going to put over a better drawing. So when you look at this free body diagram, it seems like the left force equals the right force. And now our up forces need to equal our downward force. So I have a little bit of force of tension in the y direction from the left rope. It's about that big. And then I have some from the right rope. Maybe it's that big. So this is my force of gravity. Now the question is, which has more tension, this guy or this guy? And so if the x components are the same, but this one has a smaller y component, it will have a smaller overall force of tension. The other way you can think about it is the right rope is supporting most of the weight, and the left one is just sort of pulling it to the side. So the force of the right rope is going to be greater than the force in the left rope. You see that again in this example, where now it's pulling one rope, the right rope, is pulling exactly horizontal. And so its free body diagram, you get the right rope, force of the right rope, and then we get this force of the left rope, knowing that this amount here is going to be about equal to this. And then we get our force of gravity. Now, if this was the same ball in each of these, the force of gravity should be the same in all of them. So technically, this force of gravity should be really big, which means that this is going to need to be bigger, maybe something like that. Okay, so again, which one has a greater force? the force of tension in the right rope or the force of tension in the left rope? Well, it's pretty apparent. Let's make this one bigger to equal this. It's pretty apparent here that the force of tension in the left rope is going to be bigger because it has both tension in the x direction and tension in the y direction. So the right rope just pulls it to the side, where the left rope is holding all of the weight of the ball or whatever this object is.